Hi, I'm Ms. Wong. Let's look at distance and midpoints of linear functions. To find a midpoint, we have 2 points here. We have to find the middle of the 2 points. How would we do this? Well, we can see that the midpoint of 3 and 1 is 2. How do we get 2 from 3 and 1? We would add 3 and 1 together and divide by 2 to get 2. And likewise, to find the middle of the y values, we would take the 8 and the 2 added together and divide by 2 to get the 5. So whenever you find midpoint, you're adding the x values together, dividing by 2, and the y values together and dividing by 2, or in other words, the average of the x and y values. So let's try that. So here we have 2 points, and to find the midpoint, I will plug it into that formula. Sometimes it's good to label so you don't get mixed up between the y's and the x's. So let's plug that in. So the 5 plus 0 divided by 2 gives me the x, and the 6 and the 2 added together divided by 2 gives me the y value. 5 plus 0 divided by 2 is 2.5. 6 plus 2 is 8 divided by 2 is 4. What about a question where it's not asking you to find the midpoint, it's given you the midpoint and it's asking you to find the other point that makes that the midpoint? So we would use the same formula, and now we think what it's missing. So for the x value, we have the midpoint, so the 2.5, but we're missing x2. So x2 plus 0 divided by 2 would give me the 2.5. So now all we have to do is rearrange. So times it by 2, we get 5, and so x2 is 5. So likewise, to find the missing y value, we would know that the 2 plus the missing y value would give, divided by 2 would give us 4. So therefore we can rearrange. So times it by 2, we get 8, and then bring the 2 over. 8 minus 2 is 6. So our missing value up there is 5, 6. So be very mindful when you're reading the midpoint types of questions, whether you're looking for the midpoint, in which case just plug it into that, or you're looking for one of the other points, in which case you have to rearrange a little bit. Distance between 2 points. Here we have 2 points. We could draw a nice little triangle, and we notice that it's a right angle triangle. And if it's a right angle triangle, we can use Pythagoras theorem. And Pythagoras theorem to find what C is, or the distance between these 2 points. Now for Pythagoras theorem, we have to find what A and B are. So A and B's are the sides of the triangle, and we know that this side here is 5 minus 0, or in other words, x2 minus x1, and we know this side here is y2 minus y1. So if we plug those two as our A and B's, we would get that formula over there. So try to memorize this. So because the sides is the difference in y's, we have a minus inside the brackets, and because it's Pythagoras theorem and these are the short side, we have a plus between the brackets. So have a look at this and memorize it. For this particular question, we could plug in the numbers. So x2 minus x1, 5 minus 0, and y2 minus y1, 6 minus 2. And we would get 5 squared plus 4 squared, which is square root of 41, or 6.4. Let's have a look at example 4. Find the distance between 4, negative 10 and minus 3, minus 7. So plug it into the equation and make sure you label it if you want, so that you don't get confused. So that's my x2, that's my x1, that's my y2, and that's my y1. You can just plug that into the calculator. You don't have to work it out slowly like I am here. But if you're doing a test without a calculator, then you'd want to do this. Be very careful here. You have a lot of negative numbers. For example, minus 3 minus 4 is minus 7, but minus 7 squared is positive 49. So be mindful when we have brackets and it's squared, it gives us a positive. When the minus is outside with no brackets, and when you square it, you obtain a negative. One more example, find the distance between minus 4, 1 and 4, 7. So again, write the formula out. You can label x1, x2, y1, y2 if you want. Plug in the numbers very carefully, especially with the negative numbers, and then use a calculator, or let's solve. 4 plus 4 is 8, 7 minus 1 is 6, 8 squared 64, and 6 squared is 36. This one's a pretty one. It becomes square root of 100, which is 10. So the distance between those 2 points is exactly 10. One last example. Example 6. Jack and Jill are standing at the following locations. Find the distance between them. Are they social distancing? So social distancing is 1.5 meters apart. So I'm going to label them so I don't get confused because there's decimal points. I'm going to write the formula, and now I'm going to plug in all the values to double check that's, oh, I've done them the other way around, but it's still the same answer. So I've done y's over there and I've done the x's over there. As long as you're consistent, that is fine. So now we have 1.44. So Jack and Jill are being naughty. They're not social distancing because the distance is below 1.5 meters. That's it from me today. Thank you for watching. Make sure you memorize those 2 formulas, and I'll see you next time. Bye.